Well, welcome. As we continue along in the course, we have another week, two lessons of statistical reasoning to go. So, with that in mind, let's get right at it. It is week number 10. Now, it's not week number 10 calendar wise because we had that week off, but it is our 10th week of lessons. This is lesson number 19, and our agenda for the day is, as usual, for the first day of the week, some praxis prep, review material, new material. That's what we're going to work our way through today. Now, the praxis obviously is a very important test, and what we're trying to do is to familiarize yourself with certain topics that are likely to be on your test, and then to look at it with a sense of developing not only understanding of the material, but a little test savvy to be better test takers. Well, this is a stop and start moment. We've done a few of these Pythagorean theorem problems. Why don't you get started? So the only figure that a Pythagorean theorem works in is a right triangle for your purposes. And what we're going to do is we're going to say leg squared plus leg squared is hypotenuse squared. Now, a lot of people, most people say a squared plus b squared is c squared, and that's fine. You can do it that way. The only thing is you must remember that c must be the side that's across from the hypotenuse. For those of you going into a teaching career, I vividly recall when the state, New York State, gave their state test, and then they turned around and they said, okay, you know what we're going to do? We're going to turn around and switch where the C is. We're going to put it on one of the legs. And every teacher who taught a squared plus b squared equals c squared, their students got crushed on the question. I never taught it that way. I always went, I had changed from when I did it the other way. Leg squared plus leg squared is hypotenuse squared. So that's why I'm partial to it. Now in this problem, the hypotenuse is across from the right angle and the legs make up the right angle. So that's n squared plus 15 squared equals 17 squared. So I know that because 17 is the hypotenuse, that's why it equals 17 squared. And the two legs are n and 15. Doing a little math here, 15 squared is 225, 17 squared is 289. Subtracting the 225, I get n squared 64. So remember, we're trying to undo here, and the undo of squaring is square rooting. So the square root of 64 is 8, and that is the value of n. Let's do another Pythagorean theorem question. Okay, so this time, again doing leg squared plus leg squared is hypotenuse squared. In this problem, the n is located on the hypotenuse. And I want to develop a thought here. The two legs are 7 and 24, so 7 squared plus 24 squared is n squared. 49 and 576 is n squared. 625 is n squared. Square root, n is 25. Now, the thought I want to pursue here a little bit is that in this particular problem, you added the squares. And in the previous problem, you wound up subtracting from both sides. So there is no golden rule that says you always add or you always subtract. The only golden rule is that you substitute properly for legs and the hypotenuse, and then you go where the equation leads you. If the equation says, oh, I got to isolate the variable, hey, wait a minute, they're already on the same side, then you just do the same operation. If it says to you, I got to isolate the variable, and you say, wait a minute, they're not on the same side, then you have to subtract so that you get the variable by itself. All right, next up, go ahead. These are all old praxis questions, by the way. All right. So when is the ibuprofen level in the bloodstream increasing? It is increasing from time 0 up to, I'm guessing that's about 3/4 of an hour. Okay, so from time 0 up to about 3/4 of an hour. After that, you can see, if you look here, the graph is increasing the amount of ibuprofen. After that, it decreases. Next up, go ahead. Okay, so less than's an interesting phrase. there's a less than in an algebraic sense, and there's a less than in terms of like greater than, less than symbols, okay? This problem is not doing that. It's asking you for an expression. Expressions never have equal signs. They never have less than symbols. They never have greater than symbols. So immediately you can throw choices A and D out. They're not expressions. Only B and C are expressions. So the question is, well, let me read through the beginning of the problem for you. There are S steps from the pedestal to the head of the Statue of Liberty. The number of steps in the Washington Monument is 27 less than 6 times the number of steps in the Statue of Liberty. That's an enormous number of steps, which represents the number of steps in the Washington Monument in terms of S. So it's 27 less than 6 times the number of steps. So my question is it 27, choice B says it's 27 less than the number of steps, then times it by 6, or is it 27 less than 6 times the number of steps? Well, it's choice C. Okay, so just a little careful reading on that one. Don't be intimidated. Take your time. Eliminate. That's the test savvy component here. Eliminate based on the definition of an expression. It never has a less than symbol in it. It never has an equal sign. It never has a greater than symbol. And realize, okay, we must be talking about less than in terms of subtraction. Is it B or C? Test them. Oh, the only logical answer is C. Next up. Okay, so key word here. I'm going to tell you a story. Oh boy. I love to fish, as you sure noticed. And one of the things I loved to do was fish Montauk. Now, before I saw the light of fly fishing and how superior it was, back in my heathen fishing days, I used to surf fish. Oh God, I hate to admit that, but I did. And one of the most popular places in the world to surf cast is Montauk Point. And the actual point of Montauk, underneath the lighthouse, there's all of these rocks, very big rocks, like the rocks you would find at a jetty. And the people who fish those rocks are very much regulars. They have a particular system. There's what you call a rip, which is a strong current that comes out from across that point. And you have to cast, there's lots of people there. And unless everybody kind of casts in the same direction and then works their lure back in the same direction, you're going to get a massive number of tangles. So the guys who fish under that light know what they're doing. And one of the guys who used to fish under the light, his nickname was Tiny. And Tiny was anything but. I gotta guess Tiny was in the 600-pound range, 6'5", 6'6", 600 pounds. And, you know, the guys who fish under there, there's a lot of spray from the ocean waves crashing on the rocks. And so they go there in waders, and they're all decked out. And when you fish with a surf rod at minimum is 9 feet long, but you really don't use 9-foot rods under the lighthouse. You typically use an 11 to a 13-foot rod. And then you're whipping around these lures that have 2 sets of treble hooks, and each treble hook has 3 hooks on it. So what happens is the fishing there is best at night. And people, they kind of stake out their own rock, and you don't get a person on every rock because you need room to work that really big rod and all of those hooks so that people don't hook each other. So one day Tiny's on his rock and he's getting ready to fish, and this guy kind of comes up and he stands on the rock next to Tiny, right where Tiny's going to cast. And Tiny kind of tries to politely explain the rules to him. And this guy, he didn't understand. He just read the newspaper that said Montauk was really hot and on fire with fish. So he went out there. He did not have waders. He had his own rod, just bought it from a store. And he had capizios, which are a kind of dance shoe. He didn't have, I mean, you talk about someone who was not dressed for the occasion. So the salt spray's coming up, the whole deal. So Tiny politely explains to him that he can't stand there and that he needs to go to another rock. And this guy, being from Brooklyn, copped, you know, your stereotypical Brooklyn attitude. And he goes, "You can't tell me where I'm going to fish." And Tiny goes, "Well, this is a system we have here. This way we don't get tangled. Won't you tell me I'm going to fish here?" And they get into this big argument, and they're going back and forth 3 or 4 times. And then Tiny's getting angry, but generally, people love Tiny. He's generally a pretty nice guy. So then this guy from Brooklyn just looks at him and goes, listen here, fat boy. And at that point, Tiny goes, magic word, magic word. And he grabs the guy, picks him up over his head like a professional wrestler, and throws him in the ocean. So what do we take out of that? Magic word, magic word. There's magic words in these problems. So the first thing that it talks about here, and we don't get magic right away, is that a $1,000 lottery winner had 35% deducted for taxes. Then it asks how much the winning check was. So first, let's see what 35% of $1,000 is. 35% of 1,000 is 0.35. That's what we get for converting it to a decimal. We did that earlier in the year. Of means multiply, so times 1,000 is $350. Now we get to magic word, magic word. The magic word in this problem is deducted. So if you are deducting something, you take it away. So the 1,000 you won, take away the 350 for taxes, means there's $650 less left for you to win. Kind of depressing, isn't it? You win like $1,000 and you're like, oh yes. And it still is a blessing to get $650. Don't get me wrong. But you think you win 1,000 and you don't win 1,000. Taxes just don't work that way. So $650 is the amount that you get. So there is some work on praxis type questions.